Okay students, let us discuss now some numericals which are related to the topics that we have discussed and derived till now. So the first question is like this. Well student, the question is like this. A coil of 100 turns, 5 centimeter square area is placed in an external magnetic field of 0.2 Tesla, which is also Weber per square meter, in such a way that it makes an angle of 30 degrees with the field direction. Calculate the magnetic flux through the coil. Well, let us record the data which is given to us. This will always help us solve the question in an easy way. It says n is equal to 100. Area is given as 5 centimeter square. Let us convert this into SI units of square meter. So 5 into 10 raised to minus 4 square meter. External magnetic field, so B is given as 0.2 Tesla. Now it makes an angle of 30 degrees with the field direction. So here we can say phi is equal to B dot A, right? We know this, correct? Phi is B dot A. So therefore I can write phi is equal to BA cos of theta, and there are n turns. Here phi will be what? NBA cos theta, because there are n turns. Now see, it says angle 30 degree with the field direction. See, if you see it in the form of a diagram, then it is this way. This is plane of a coil. Magnetic field is this way. This is your area. This is your area, coil. Now what it says? It makes an angle of 30 degrees with the field direction. So this angle is 30 degrees. And what we need? We need angle with the normal. This is the normal. So this angle is our theta. Theta is the angle between the normal to the plane of coil and the field direction. So theta will be how much now? This theta will be 60 degrees. So what we get now? N is 100, B is 0.2, area is 5 into 10 power minus 4, and cos 60. This is to be remembered. Just because an angle is given in the question doesn't mean you use that here. No, you have to be very careful. It is measured with what? So this gives us how much? This is 100, this is 1, and this is 10 power minus 4, and cos 60 is half. So you get this as 5 into 10 power minus 3 Webers, or you can write it as 5 milliwebers. That is exactly how we have to solve. Students, please concentrate on how to find angle theta. This is what is the twist in the given question. Now let us take the next question. The next question is like this. A coil of n turns, area A is placed in a uniform transverse magnetic field B. It is turned through 180 degree about its one of the diameter in 2 seconds. Find the rate of change of magnetic flux through the coil. First of all, we can say magnetic flux phi is B dot A. This is known to us. This is what we know. Phi is B dot A. So this can also be written as BA cos theta. Here phi, initial flux phi is, there are n turns, n B A cos 0 degree. This is initial flux. So this is NBA. final flux is NBA cos 180 degrees. This is what we have. So this is how much? Minus of NBA. So what is change in flux? Therefore, change in flux delta phi will be given as final minus initial. So this gives us final is minus of NBA minus NBA. So therefore what we can say? Change in flux is minus 2 NBA. Now what is asked? Rate of change of flux. So therefore rate of change of flux is delta phi by delta t. So that is minus of 2 times NBA upon 2, because it changes in 2 seconds. So that is minus of NBA. This is exactly how, please understand this. This is initial flux. It says that it is placed in a uniform transverse magnetic field, which means that the magnetic field is perpendicular to the plane of the coil. So normal to the plane of coil will be parallel to the magnetic field, hence phi is 0 initially. Now if it is rotated by 180 degree, it is this way, then what happens is we get 180 degree rotation. So cos 180 is minus 1. That is exactly how we can find out change in flux and hence rate of change of flux. Well students, the next question is like this. A square cube of side A is placed in a uniform magnetic field as shown in the figure. Find the magnetic flux through each face. Each face. There are 6 faces, correct? You can visualize the room where you are sitting, something like that. 1, 2, 3, 4, 5, 6 faces are there. Now first I am taking face ABCD, or first of all we know phi is equal to B dot A. It's a dot product, right? So phi is equal to BA cos theta. So now I will take first face ABCD. Now ABCD is this face. See, B is this way, and if I drop a normal to this face, it is in this direction. So the angle between the normal and the magnetic field is 0 degree. So for this face ABCD, theta is 0 degree. This means phi with ABCD will be B, A is A square and cos 0 degree. So phi ABCD is B A square. This is what we can say. Now let us take face EFGH, this face. Which is that? This one. This face. Now observe here, this is the direction of B, correct? And normal to the face is in this direction. So what is the angle between them? Correct, 180 degree. So in this case, theta is 180 degrees. So therefore, phi EFGH will be what? B A square cos 180 degree. So phi EFGH will be minus of B A square. Now 2 faces done. Let us go to other faces. Let us say face, I am taking CDHG. See, please concentrate. This is the direction of B. Normal to the face is this way. So what is the angle between them? The angle between them is 90 degree. So for this face, theta is 90. So from this we can say cos 90 is 0. So the face CDHG flux is 0. Same thing you can say about this face also. Here the normal is this way. So the face ABFE all is also 0. ABFE, this is also 0. Same thing happens with BCGF. So B, it will also happen the same thing, face BCGF and ADHE, there also flux linkage is 0. Why is it 0? Our interest is to find the angle between the normal to the plane of coil and the direction of field lines. That is what you have to always find out, and then you have to go for it. Simply just because some angle is given, don't use that. Read it properly and then use it. The next question is like this. The magnetic field in a certain region is given by, so B is given as 4I minus K cap Tesla. This B is given in terms of unit vector. How much magnetic flux passes through the loop of area? So area is given as 0.1 square meter. In this region, if the loop lies flat in XY plane, so this is XY plane and the coil is in XY plane, it lies flat in XY plane, coil is this way. Normal to the plane of coil will be this direction, so which is that? Z axis. So I can write A vector, if you write, then it becomes 0.1 K cap. Normal to the plane of coil, XY, this is XY plane, so Z axis is perpendicular to it. That is exactly how we get. Now, flux is what? B and dot product with A. So B is what? 4I minus K dot 0.1 K. Take the dot product. I dot K is 0, K dot K is 1. So this is minus of 0.1. This is exactly how we can use the concept of vectors dot product to evaluate such questions. Well students, the next question is like this. The magnetic flux in Webers linked with a closed circuit of resistance 10 ohm varies with time t in seconds as phi is equal to phi t square minus 4t plus 1. The induced EMF in the circuit at t is 0.2 seconds is. Now, induced EMF E, we have seen it is minus of d phi by dt for one turn in the coil and minus of n d phi by dt for n turns in the coil. So differentiate this. So this is minus of d by dt of phi t square minus 4t plus 1. So it is minus of 10t minus 4. Now at t is equal to 0.2 seconds, E will be what? Minus of 10 into 0.2 minus 4. So this will give us minus 2 minus 4. So that is, so our answer here is plus 2. That is exactly how. Remember, you cannot neglect minus sign. This is a common mistake which the students commit, and you will get minus 2 volt then. Because if you don't consider this minus, you are getting minus 2 volt. Please remember that is wrong. E is minus of d phi by dt. You have to consider the minus sign as well. This is a common mistake which the students commit in the entrance exams. Well students, the next question is like this. The radius of a circular coil having 50 turns. So n is equal to 50. R is given as 2 centimeter. So take it as in SI unit 2 into 10 power minus 2 meter. Its plane is normal to the magnetic field. Plane of the coil is normal to the magnetic field. So we will say here theta is 0 degree. The magnetic field changes from this. So initial B is 2 Tesla, final B is 3 Tesla, and the time taken is 3.14 seconds. Induced EMF. Well, we know induced EMF is minus of d phi by dt. So this is minus of d by dt of B into A, because cos theta is 1. So this can be said as B into dA by dt plus A into dB by dt. See, by applying product rule, very important. This is very important. Please understand this. Now observe here what is changing. Flux is, magnetic field is changing, means dB by dt is changing. Area is not changing, therefore this term will become 0. So what we can say now? Induced EMF, if I take the magnitude only, not the direction, magnitude only, then I can write it as A dB by dt. So area will be what? It's a circular coil. So pi r square. dB is a final minus initial, so it is 3 minus 2. Time is 3.14. Radius is given as 2. So pi cancels out. So we get 4 into 10 power minus 4 into 1. So this gives us 0.4 millivolt. So our answer is 4 millivolt. It is given, this should be 0.4 millivolt, because 4 into 10 power minus 3 we have. So that is exactly how we can find out so our answer is third choice. That is exactly how we can find. See here, it is students, see here. dB is what? 3 minus 2, and time is given 3.14. Pi is also 3.14. 4 millivolt if you will get when the time is not 3.14, not cancelling, then only you will get it like that. Okay, so that is exactly how we can evaluate and get the answer. Please understand how exactly. See here, we have considered the magnitude of the induced EMF. That is what the question is. Well students, in the previous question we have done E is equal to minus of d phi by dt. This was for 1 turn. Now E will be minus of n d phi by dt. This is for n turns. So what we have now? Minus of n A and dB by dt. This is what we will have. So this will give us what? Minus of n. N is 50. Area is pi. R square is 4 into 10 power minus 4 into, we have dB is 3 minus 2, and here I have 3.14. Pi cancels out. So what you get now? Minus of this is into minus 4. See how you can keep on changing based on the data which is given. Here it is 50, so we will take it as 50 turns. So 50 for 200 and you get 10 power minus 4. This is same as minus of 2 into 10 power minus 2. You can say this as 20 minus 20 into 10 power minus 3 as well, and you can write it as minus of 20 millivolt. This is how we can find out the value of induced EMF. Well student, let us take the next question. This is conceptual question. A short bar magnet is allowed to fall along the axis of a metal ring placed in the horizontal plane. Let us say this is the metal ring placed in the horizontal plane. This is the axis. Now a short bar magnet is falling this way. In 1 second, what is the distance starting from rest? So S is ut plus half a t square. We can use this equation. It is starting from rest, so u is 0. Therefore we can say h is equal to half g t square. So that is half. Let us say g is 10 and this is 1 square. So the height it will fall is given 5 meter. This is not the answer. Why? Because it is given that it's a metallic ring. So therefore, with a metallic ring, whenever there is a change in the flux linked with the coil, an EMF will be induced. Observe, the flux linkage is increasing as the magnet is coming closer and closer. Flux linked with the coil is increasing. So in the coil, EMF will be induced so as to oppose that increase. Means it will be induced EMF will be in this direction. This is B induced. So it will try to oppose the motion of this magnet which is coming down magnetic field. Because of that, if there is no such opposing force, it should be 5 meter in 1 second, but there is an opposition to the motion of the magnet. Hence, it will be less than 5 meters. See in the choices, only one choice is given which is less than 5 meter. So we can say distance may be 4 meter. That is exactly how we can establish. Please read the question and try to understand properly what is asked. They are simple questions. Small mistakes cost us a very lot in the entrance exams.